So, what is another name for BD? So, what kind of line is BD? A segment. How do we know it's a segment? Yeah. No arrows. It's just got a straight line above it. So, when you name a line segment, can you just switch the letters? Sure can. So, DB is the only answer that is possible. Because BD is from here to here, if you named ED, that would not be the same amount of space as BD. But if you said D as in dog, DB, that's the same as BD. Capiche? Capash. That's the correct answer to that.
I thought it was capuche.
Capuche? I mean, you could say that. AC, what is another name for AC? CA. Line above it. What is another name for ray AE? Let me describe it first. So ray AE, what is the end point we have? A is the end point. A. All right, and then it goes infinitely in the direction of what letter? E. So we need to rename it. When you rename it, it has to have the same end point, which would be A. So if you start at A, how do we go in the direction of E without naming E? We could go C. Because that arrow represents to infinity and beyond, we could say C. Name all the rays with the end point E. I don't have enough room there. Can you name one? Kamari? Jamari. Sorry. I'm sorry. I've been doing so good with names, too. ED? And what has to go over it? Arrow pointing right. Can you name another one, Noah? EB. Yep. Kaylee, can you name another? EA. And then Alana, can you name another? EC. Name two pairs of opposite rays. So this is a struggle for some students. When you put on a pair of shoes, how many shoes do you put on your feet? Two. I really hope that you do. So when you name two pairs, you're naming a pair, which is 2, and then another pair, which is 2. So you're naming 4 different things, just to keep you aware. So let's say we had EA. What is EA the opposite ray of? EC. That's correct. All right, so that is one pair. Another pair, what do we have? EB and ED. Sorry, D and B sound very similar. All right, and then name one pair of rays that are not opposite rays. You will see this on your quiz because I made them this morning. So let's say you had EA. What is EA not an opposite ray with? EB or ED. I need to sneeze, but I can't. Oh, it's passing. Nope. Oh, that's just awkward. Okay, so EB is not an opposite ray with EC. You could have named EC and ED, ED and EA, any of those. So just a pair that are not opposite. We are going to learn 1.2. It is a pretty simple section. You're going to learn some new terms. But here is the gist of the most important part. Okay? How many of you at least have seen football? Or played anything to that extent? Okay, so how many yards is it from the front of the end zone to the front of the end zone? 100. Okay, how many of you have played before? Okay, Justin is running down the field. He's running pretty fast. He's kicking up dirt. He's got a smile. His hair is waving back. He's running so fast. Okay, pick a number between 1 and 100. How far does he get down the field? 30, that's nice. Well, I drew him a little far over, so we're going to say, let's say 60, yeah. So if he runs 60, okay, it's a punt return, man, he bobs, he weaves, he jumps, he dodges, here he is, 60 yards. How many more does he need to get to the end zone? 40. Congratulations, that is literally half the lesson. So this concept will be the second half of the lesson, but it's called the addition segment postulate. And we'll talk about it in a minute. Some terms you need to learn first. The word postulate is the first on your notes. Rules that are accepted without proof are called a postulate. So basically, things that we have to say out loud that aren't like, they're kind of like duh moments. And I'll show you one in this section. So it's something that we really can't prove, we just accept it to be true. The second kind is a theorem. Those are rules that are proven, not a D, proven. Can anybody name a famous math theorem? The Pythagorean theorem. Good job. It took my other kids saying the flat earth theorem, stuff like that, before they got to Pythagorean. The Pythagorean theorem. So it has been proven, so we use it. Postulates, they really can't be proven. They're just kind of common sense. But we apply them. Okay? So these are 2 words. They are on your quiz. You'll need to know the difference. Okay? So theorem, you want to think of the Pythagorean theorem. It's definitely been proven. Postulates have not been proven, but we accept them as truth. We're going to learn about the ruler postulate. The points on a line can be matched 1-to-1 with real numbers. So what that means, and actually it'll show you. Name of the points, you can assign a number. So instead of thinking x1 and x2, give me any number in the world. Well, not like billions, but
2.
Sure, 7. We'll say -7 and 2. Okay, so you can assign points, numbers, and eventually it will ask you to find the distance between the 2. The real number that corresponds to that point is called the coordinate. So this -7 is the coordinate of A, 2 is the coordinate of B, that kind of thing. The distance between the points is the absolute value of the difference. So what does absolute value do? Does anybody remember how to describe it? It's always the positive. There you go. She was getting there. It's always the positive. So here's why this was created. Okay? You guys hopefully have been on a road trip, at least to your grandma's house or wherever you go. If I go 50 miles to my grandma's house, I don't have a grandma, but if I did, 50 miles to my grandma's house and I drive 50 miles back, okay? Just because I went there and back does not mean I drove 0 miles. What it would be is the absolute value. So that would be 100 miles. You've also never heard of, let me measure the side of this table. It's -2 feet. Okay, that's not a thing. So absolute value is created for distance and then for measurements of things. So this is the formula. There's a space on there to write the formula. Here's another way to do it. I'm not like a lot of teachers, I guess, or math teachers. I know why x2 comes first, but it doesn't have to come first. You could do x1 minus x2, and it's literally the same answer. They use this pattern because if you remember when you do like slopes, do you remember like the y2, y1? Yes. Okay. The reason that is in place is because of when you get to calculus, you do have to have them in order. But lower than calculus, because we are lower than calculus, you do not have to have them in that order. Okay? I prefer 1 and 2 because it's easier. All right. We're going to learn a new word. This word will be carried all throughout geometry. It's called the word congruent. Line segments that have the same length are called congruent segments. I believe that is on your paper. So when they have the same measure, that's called congruent. So instead of saying the length of AB is equal to the length of CD, you would say AB is congruent to CD. All right, and then there's a symbol. If you see it just popped up, it's like a squiggle with an equal sign. You will see that forever and ever and ever and ever in this class. Maybe not forever and ever and ever, but a long time you'll see it. Okay, and it means is congruent to. So just like we've been learning, if you have a line, okay, you have AB, right? And we have segment CD, so they're both line segments. This dash means that they're congruent to each other. So what we would do, instead of writing line segment AB is congruent to line segment CD, we would write, oops, that's not an A, AB, and then the congruent symbol, which is a squiggle and an equal sign, and then CD. So this says the sentence AB, segment AB is congruent to segment CD. So we do this rather than write out the full sentence. All right? So equal, you don't want to use because it means their lengths are equal. Whereas you want to say congruent because equal means they're literally the same thing. Same letters, same length. Congruent means they have the same measure. They're different lines, but they have the same measure. So we use congruent more often. The last thing about congruence, you see how these tick marks are one of them? Yes, no, maybe so? Okay. So whenever you have other lines, let's say we had EF, what's next? GH, A, B, C, D, E, F, G, H, yeah. Yeah, thank you. So let's say we had this going on. What do you think AB would be congruent to? GH, because their tick marks match up. CD would be congruent to EF, because CD has 2 tick marks and EF has 2 tick marks. So you'll see that kind of a lot when we start learning and building on this. And we do that with angles too. All right? Questions about congruent? Yes?
So ain't nothing just gonna be like, like something like mess you up. Like say if they the same thing, but it would be the wrong answer because like you're not.
So you're saying if they don't look alike?
Yeah.
So I would always go by these tick marks. Because either I'm making the test or quiz, or I have a bunch of problems that I've already made by the company of your book. But they're not always to scale. They usually look correct, but they might be a little off. So you would always want to go with this. They would never have them matched. Like, I know mine aren't perfectly matching because I'm just not perfect. But if it says that they're congruent, then we just believe them to be congruent. Does that make sense? It would never trick you and say, like you have this long line and then this short line. It would never say that they're, It would never say that they're congruent like that because that's really obvious that they're not. Does that make sense? So it could be off by like a little bit. Like mine's a little bit more, I think mine looks a little longer. So this could happen, but definitely not something as drastic as that. Did I answer your question? Okay. You do mumble a little bit. Okay. Next time, can you talk a little bit like louder maybe? It would help. I'm saying this out of love. I hope you know. Okay. All right. So the second thing that we do is the last thing before we get to the football part that I just showed you. If you flip to the next page of your notes, comparing segments for congruence. This really brings in being able to put points on a graph and then deciding whether 2 lines are congruent. All right, so I did not give you an X and Y axis, so you're going to need to draw one. So go ahead and draw an X and Y axis. Which axis always goes up and down? Y. And then that means the other axis is X. Whenever you're looking at coordinate points, which letter goes first? X and then Y. You can always remember because X comes before Y in the alphabet. So when we graph these points, we always do the X first. So if we're going to graph the letter J, it says plot J, K, L, and M in the coordinate plane, then determine whether JK and LM are congruent. Okay, so JK consists of these 2 points, and LM consists of the second 2 points. All right, so let's graph. Starting at the origin, which is 0, 0, we have -3. So that's the left or to the right? left, and then positive 4, which would mean up, right? 1, 2, 4. What'd you say? Oh, okay. Sorry. I thought you were like to the left, like questioning that we were supposed to go to the left. J, and then we have K, which is positive 2, 4. So you start at the origin again, go over to the right 2, and then up 1, 2, 3, 4. So here's K. So again, we went over 2, and we went 1, 2, 3, 4. All right, so JK is a line. Do y'all see that written in the directions? So if it's a line, what do you think we can do? We can connect them. So go ahead and connect them. I'll go ahead and do the second one in blue. L is 1, 3. So positive 1, we're going to go to the right 1 and up 1, 2, 3. That's L. And then M, we're going to go to the right 1 and down 1. What is it, 2? 2. M. Connect those. All right, so from here we find the lengths. JK, how do you think we can find the length of JK? You count them. JK is 1, 2, 3, 4, 5 boxes, so its length is 5. And then the length of LM, we can count those boxes. It's 5 as well. So are they congruent? Yes. So we're not finished with the problem. Oh, I thought I heard a knock. So we will say JK is congruent to LM. So here's what I'll say. Apparently I missed writing the letter L. There you go. So you see how I didn't put a line above it? Y'all see that? Whenever you see 2 capital letters of a line with no line above it, this means the length of them. So the length of LM is 5. The length of JK is 5. I'm not going to take off points if you just keep writing the line over them. I don't care. Questions about this? All right, now we get to the segment addition postulate. We have 2 more things to go. We have this common sense. This is what I meant by a postulate. I just have to say this to you. When 3 points lie in the line, you can say that one of them is between the other. So if you have 3 points on a line, like this, A, B, and C, then point B is between A and C. So whenever you see the word between in geometry, they have to be on the same line together. What does it mean to be on the same line? What is that term? Collinear. Thank you, Alana. So something like this, E is not between D and F because it's not on the line. Are we all okay with that fact? We can accept it? Yes, no? Maybe so. All right, so now the segment addition postulate, you don't have to write this down. So what happens is the full length of the line, so if you have AB, BC, the full length of the line is AC. You can take the pieces and add them, and add them up. So AB plus BC equals AC. So what we did earlier, we had 100 yards to run, and he ran, how much did we say? 60. Okay, so you guys already used the postulate to find out that what's left of the 100 is 40. Okay, so sometimes you'll be given the full length of the line and a piece of the line. Sometimes you'll be given the 2 pieces of the line. So when you're given the 2 pieces, you literally add them together. 40 plus 60 is 100. Okay, so you should like this section. It's yeah, it's a good one. All right, so let's do our 2 examples. So again, you see DF with no line above it. That means that we're finding the length of it. So the length of DF, what do you think that we do? We have DE is 23 and EF is 35. So what do we do with those 2 things? Add them. 23 plus 35 equals 58. But we're not just going to circle 58. We're going to say DF equals 58. Reason being, you could be finding multiple things in a problem, so it's just easiest if you write on the side the final answer. Questions about the first? We are still on the notes. Are you looking for what we're doing? We're on the notes still. We haven't touched that book.
Yeah.
Nope.
Oh.
We're on right here.
I was confused.
It's okay. All right, so now we're finding GH. So we have the full length of the line is 36. So can GH be bigger than 36? Absolutely not. So here's what we do. Well, actually, you can tell me. What do you think we do to find the missing piece out of our 36? Subtract. 36 minus 21 equals 15. 15. So right on the side, GH equals 15.
Every time it's above the line, we subtract.
It won't always be like above it necessarily. But whenever you have the bigger part, like the full length of the line, you always subtract. Questions about this concept? Okay. We're going to do this last one. It's on the very bottom of that page. The cities shown on the map lie approximately in a straight line. Find the distance from Tulsa, Oklahoma to St. Louis, Missouri. So let's see. How far is it from where we started at Lubbock? We have discussed it, and that's just how we're gonna say it. I have no idea. Lubbock, and we're going to St. Louis. How far is it from our starting point to our ending point? 738. So we have the full distance. How much have we traveled already? 377. So we're going to subtract to find out what's left. So that'd be 361. So your answer should be 361 miles. So when you have a real life problem, make sure you actually answer it. The last thing that you're going to do, you're going to flip to the very back and you're going to do the review section. Should take a couple of seconds. Don't use your calculator, just test yourself as we're going to go over the correct answers. The very first, -2 divided by -8. So what's a negative divided by a negative? Okay. They're both divisible by 2, so your answer should be 1/4. Someone asked me earlier, is 1/4 the same thing as 4? Would you rather have a fourth of a pizza or 4 pizzas?
You talking about like a whole piece?
4 whole pizzas. Just kidding. I was going to say $250,000 or $4 million, but I mean, I would appreciate any sort of $1 million, you know.
I'd rather take the 1/4.
I'm sure like I make like what, 1/36 of $1 million?
Oh.
Probably. Something like that. I don't know. Okay, -9 divided by 9. I do like when you box your answers so you can circle them. Just show me where your answer is. -8 plus 3. -5. -11 minus 10. -21. 4 times -12. -48. -7 minus 3. -4. Minus makes a plus. And then -1 times 7 times -12. Positive 84. Because -1 times 7 is -7. -7 times -12 is positive 84. -21 divided by 7. I almost said the number 3 out loud. -3 times -4 times 3. 36. Perfect.